Hey everybody, so right now we're going to be watching the Nvidia CEO keynote speech. So this has been a big deal. Like I've been seeing it all over social media, and honestly as well, I want to watch it for myself and because I need to educate myself. So we're going to be like taking notes here. So like whatever thing he talks about, I may actually just use my phone actually, just like create a separate tab and like talk about the like just so I could keep like on top of like the AI stuff that he talks about, just so we can like look into it further like later on. So like I think I just got a message. All right, so like right now we're about to watch Jensen Huang, and I'm really excited for this. I hope you are too. So we're just gonna watch it and then comment along the way. And but really we're here to learn together. And this is just to learn. Like we're not trying to get anything out of this video besides learning and seeing like how we can position like our knowledge to like help us do our jobs better. All right. Why are tokens fundamental to AI?
Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
So what are tokens, huh?
And give us peace of mind when we need it most.
Hi, Rota. Hi, Anna. It's good to see you again.
Hey, Emma. We're going to take your blood sample today, okay?
Don't worry, I'm gonna be here the whole time.
Wow.
Bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us.
California definitely would need an AI like that.
Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward.
Yeah.
Small step at a time. And one giant leap. Together.
This is a really cool intro. Could you imagine like
And here
waking up and
is where it all
going to sleep and not like being a part of this conversation? Like I want to be a part of this conversation. So like first thing we're gonna need to talk about later on is
Welcome to the stage, Nvidia founder and
why are
CEO,
tokens
Jensen
important
Huang.
for AI. Woo! Jensen!
CES!
Woo! Nice jacket, buddy.
In Las Vegas?
You should have got a Gucci jacket or something.
Jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all.
He should have got.
If this doesn't
He should
work
got
out,
a
if
Gucci
all of you
jacket.
object, well, just get used to it. I really think you have to let this sink in.
Obviously, his jacket is crocodile or
In
something like
another
that.
hour or so, you're gonna feel
It's
good
cool.
about it. Well, welcome to Nvidia. In fact, you're inside Nvidia's digital twin. And we're going to take you to Nvidia. Ladies and gentlemen, welcome to Nvidia.
What is Nvidia Digital Twin?
You're inside our digital twin. Everything here is generated by AI.
That's insane.
It has been an extraordinary journey, extraordinary year. And it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtua Fighter.
Cool.
6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible.
Mm-hmm.
And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible.
All right. I mean, the graphics are a little bit better.
After that, 6 years after 1999, we invented CUDA, so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it.
Okay.
CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Kershevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and
Perception.
the rest of it is history.
AI.
AI has been advancing at an incredible pace since.
Generative
Started with
AI.
perception AI. We now can understand images and words and sounds.
Hold on. I just gotta want it.
And
Agentic physical.
perception AI.
Okay.
We now can understand images and words and sounds.
Agentic
Generative
AI.
AI. We can generate images and text and sounds. And now, agentic AI.
Okay.
AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI.
Physical AI.
2012.
20.
Now, magically,
Wow.
2018, something happened that was pretty incredible.
This is good information that we gotta look
Google's
into.
Transformer was released as BERT, and the world of AI really took off.
Mm-hmm.
Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just
Hand
a new
coding,
application
instruction, CPU
with a
software.
new
She learned no
business
language.
opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works.
Okay, so get to it.
Computing is revolutionized in every single layer.
Did he prepare for this?
Hand coding,
Yes. Obviously.
Instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed.
I had to just like.
An incredible
I gotta blow my
transformation
nose.
in just 12 years.
Oh, my nose.
Well, we can now understand just about any language. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them.
Okay.
Applications are just completely endless.
Yeah,
In fact,
okay.
almost any AI application that you see out there, what modality is the input that it learned from?
Mm-hmm.
What modality of information did it translate to?
Okay,
And
what?
modality of information is it generating?
Alright.
If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI driven, AI native,
What is AI
at the core
modality?
of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built.
We kind of just have to
GeForce
listen to
enabled
this.
AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
All right, what can we do with AI? Damn, I missed what the text said. You don't need actors anymore. You don't need actors and actresses. The day of these Hollywood celebrities are gonna be behind us. Standard material. RTX neural material. Oh, wow. RTX. DLSS. Former. Text to animation. All right.
Was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence.
Okay.
There are two fundamental things that we did. We used, of course, programmable shading and ray trace acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance.
AI predicts
because AI
pixels?
is a lot less computation. It takes, of course, an
What does
enormous
this
amount of
mean?
training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the
Okay.
RTX Blackwell family. Let's take a look.
RTX Blackwell family. This sounds important. Come on, I don't want to miss this, but I gotta type. GeForce RTX. It looks like a fan. Double flow through. Ultra fast G7 memory, 1.8 terabytes memory bandwidth per second. No, this thing is in the way. Nvidia Blackwell GPU, 92 billion transistors. All right, let me rewind that for everybody that it blocked. 4,000 AI tops, 92 billion transistors, 4,000 AI tops, 380 RTT flops, 125 shader T flops. All right. Yeah, I gotta find a way where to put this so it's not in the way.
Here it is. Our brand new GeForce RTX 50 series.
They made it look so cool.
Architecture. The GPU is just a beast. 92 billion transistors, 4,000 tops, 4 petaflops of AI.
How do you
3
even
times
use this
higher than
thing?
the last generation ADA, and we need all of it to generate those pixels that I showed you. 380
Oh.
ray tracing teraflops, so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images.
L'Oreal,
that
stop
are
it. It's my
because we use
cat.
AIs to learn the texture,
She's been in my room
learn
all
the
day,
compression,
so I gotta leave her
and
outside for a
as a
bit,
result, get extraordinary results.
so she doesn't get
Okay, so
lazy.
this is the brand new RTX Blackwell 59. Now, even the mechanical design is a miracle. Look at this. It's got 2 fans. This whole graphics card is just one giant fan. So the question is, where's the graphics card? It's literally this big. The voltage regulator design is state of the art, incredible design.
Why is this?
Did a great job.
Okay, that's
Here it is.
cool.
Thank you.
Buzz off software update.
Okay, so those are the speeds and feeds. So how does it compare? Well, this is RTX 4090. I know many of you have one. I know it.
That's funny. He's not. He's like,
$1,599.
this is how much it
It's
costs.
one of the best investments you could possibly make. You, for $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't
Okay.
tell me that's not true. Don't be ashamed. It's liquid cooled. Fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,599,
L'Oreal, stop.
$1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at
$500. Okay, but like, what is it actually like? I have a PC. Like, how do I actually like hook my PC up to this thing? That's what I'm trying to figure out. Like, are there
Impossible
ports?
without artificial intelligence. Impossible
Like, what?
without
Like,
the four tops,
where is
4
the
teros
advantage?
Of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1,299, this 5070 laptop has a 4090 performance. I think there's one here somewhere.
RTX 5070 laptop.
Let me show you
Oh
this.
shit.
This is a, look at this thing. Here. There's only so many pockets. Ladies and gentlemen, Janine Paul.
Janine Paul, yes.
So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense?
Oh, no more Apple computers.
Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores.
No
So
more
we make
PCs, no more
only the
Mac
pixels we need,
computers.
and we generate using artificial intelligence all the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing,
Neural rendering is the feature.
thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family.
So that's the family? Okay. Or is that family coming up?
Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at Nvidia.
Now AI revolutionizes
This is
GeForce.
literally Nvidia's headquarters.
Incredible.
Okay, so let's talk about AI. The industry
Come on.
chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations.
Wow, if it wasn't for YouTube, I wouldn't even be watching
The
this.
scaling laws says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become.
More
So
data.
the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about,
Wait, what do you say?
or the more capable your,
So
is that the more data you have,
the more data you have,
the training data that you have, the larger model that you have,
larger
and the more
model.
compute that you apply to it, therefore, the more effective or the more capable your model will become. So the scaling law
Oh.
continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think that in the next couple of years, humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data. and it's becoming more multimodal. Video and images and sound.
Than
All of
ever.
that data can be used to train the fundamental knowledge, the foundational knowledge of AI.
Multimodal.
But there are,
Okay.
in fact, two
Video,
other scaling laws that has now
sound,
emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law.
So two new
Post-training
scaling laws.
uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data
Okay, where are we?
generation.
Okay, let's just keep
These
the
techniques are
timer
rather,
up so we can know like where we are.
Akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and has an answer that we understand. Maybe proving a theorem, maybe solving a geometry problem. And so these.
All right, I'm just gonna play this at 1.5 speed, because we have a lot to get through. So I'm just gonna put it at 1.5 speed.
Problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate. Your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling
Have
is
AI
proven to be incredibly
break down
effective. You're watching
problem,
this sequence of technology
multiple
and all of these scaling laws
steps,
emerge as we
and
see
pick best
incredible
ideas.
achievements from ChatGPT to O1 to O3, and now
Yeah.
Gemini Pro. All of these systems are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some, every single cloud service provider now has systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36x2, NVLink 72x1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. It's very clear that Janine? It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second, is this a good idea? All right. Wait for it. Wait for it. I thought I was worthy. Apparently Yorker didn't think I was worthy. All right. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables, This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them.
Shipping
Manufacturing is
parts.
insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems.
Wait a minute. AI tokens. Doesn't that sound like something that we should be getting? If every single system is going to be consuming AI tokens, we should just be focusing on getting AI tokens.
Every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that can be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry guys. You see that? That's cool. Look at that, disco lights in here. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times the size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips. Okay, and we have 130 trillion transistors in total.
Okay, hold on. There's a fucking bug in my room. Shit. Ah, shit. Ah. Jeez. Ugh. Okay, this is the last time I ate food in my room because that's. Ah! Shit. Ah. Okay, excuse me, everybody. That's a whole fucking bug, bro. What the fuck? Never eating in my room again. Fuck. And my room has been a little bit dirty. Now I gotta really clean the fuck up. I have to really clean up my room because this is really embarrassing. Okay, sorry for the technical difficulties real quick. Let me take off my necklace real quick. Shit. Dang, my light is really... Yeah, this thing should not be... this thing should be wider. Look, it fell because it wasn't so wide. Damn, where the fuck that bug come from? Alright. Alright, I gotta deep clean my room. Like, this is really OD. Alright.
2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink. And we're trying to pretend about the NVLink spine, but that's not possible. Okay? And these are all of the HBM memories. 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. The Blackwell die is right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can. Thank you. Thanks. Boy, is there a chair I can sit down for a second?
Oh, he's just trying to laugh, make a joke.
Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to Nvidia and we don't have a GPU for you.
That's funny.
So we need an enormous amount of computation because when training larger models and these inferences used to be one inference, but in the future the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens can be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale.
Hold on, I just have to do something really quick.
So long as it's coming out at 20 or 30, enormous amount of content.
Alright, guys, just bear with me for like literally 1 second, quick commercial break. I just have to respond to this message before I forget. Because if I don't respond to the message, I'm just going to forget. And it's going to be like, it's going to be bad on me. Just give me 1 second. 1 second, 1 second, 1 second, please. I got to respond to this, dude. Okay, just... Okay, I'm just checking to see if it's like the same thing. Oh, fuck. It's not the same person. Shit. Or December 22nd. Just give me 1 second, guys. 1 second. Okay, so this should be good.